So after copying the STL file to the constant tri-surface, or if you have the necessary scaling of the units from millimeters to meters, so all have done. Now you are ready to go to the next step. But before that, we better to prepare our system folder by doing two things. First is copy a control dictionary, and another is copy a mesh quality dictionary. So we go back here, we go to our main path and create system folder. So in system folder, what I'm going to do is I have previously have this system folder defined here, which is for the very original control dict for the conjugate heat transfer. So I will copy this as my folder for the CHT demo. So this is one. For another one, which is mesh quality, I haven't used it before, but I can find any mesh quality dict and just directly copy any of it to here. So the mesh quality dictionary is only a control of the meshing. So actually here it's do nothing, so it just copy this file as backup. So I will do this, and the next part we are going to define the surface of this STL file. So the surface feature extract dictionary is used to let the software to extract some key geometric features. Here we have two STL file, right? We have two STL file, one called air block. If you go back, as I have copied the triceps here, the air block and water block. So these are two STL files, and I need to create a new file, and I will copy all this to my file. Remember, this one is a head file. We used to ignore this, and the OpenFOAM running will give some warning to let us add the information of the head. So I will copy this and I will save as the file to my system folder. So remember, it will be in the system folder, and I will save it as a surface feature extract, right? Surface feature extract dict. Right? They might be different for different OpenFOAM versions for this definition of dictionary. So you can define or name it as the as your desirable. So now we just go back to our OpenFOAM. So I will use foam to get to my parent parts of the running, and I can list. I will go to my run folder and I list again. I will go to the CHT demo macro HE. So that CHT demo, that is another area, demo macro HE. Right, so we have only two folders here we have defined. So I will run the surface feature extract. So basically, when I run this, if you go back to the constant folder and go to before that, we only have the tri-surface. Now it has extended feature edge fish here. So it will create a lot of information or geometric information, and also the main thing, it will create two images, which is the detailed information about the STL file we just built. So that is how to deal with the surface feature extract. This will be mainly for the snap hex mesh. It will help have snap hex mesh to log any geometric information, but it's not so necessary sometimes. So, but if you define it, that will be helpful.